Hello dear friends, today I will introduce in deeply about quantum science and quantum technologies. So what is quantum science and how does quantum technology works? So if you haven't subscribed our CyberAsia channel yet, then please subscribe our CyberAsia channel and hit the bell icon for more updates. And so without waste our valuable time, let's start the video. In this video, I split the topics into three main topics. In the first part of the course, we will describe fundamentals of quantum mechanics. In that parts, we will introduce, for example, properties of quantum mechanics such as wave particles, duality. We will talk about entanglement, uncertainty principle, inheritance, and try to build a mathematical ground for introducing some of the more complex quantum mechanical phenomena. In this second part of the course, we will talk about quantum resources. By quantum resources, I mean the type of quantum entities we would use to build quantum technologies out of. For example, we use atoms, we use ions, we use superconducting circuits, and use photons to quantum technologies, various quantum technologies, so that this kind of resources would be introduced in the second part of the course. And in the last part of the course, we would go over various quantum technologies such as quantum sensing, quantum communications, and quantum computations based on the quantum resources, and we will see how various technologies can be built using quantum resources. There are various quantum technologies that we'll cover in the course in the video. One of the main drive for quantum technology in the course, one of the main application of the quantum mechanics and quantum technologies, there has been various platforms that are being developed as a result of this. For example, IBM and Google are developing superconducting quantum computers, and also atomic platforms are being used to develop processors, and this is another topics that we would cover in this course. Photonic is another topics that will cover, which has applications both for information processing and as well as communications. In term of communications, quantum communications is another important applications of quantum technologies, where you can securely communicate between two parties, and this is done using light that carries quantum information, and it turn out the laws of quantum mechanics allows to you securely communicate between two parties and two persons, and be sure that no one can hack your information and no one can crack your data. Another applications that will cover in this course is quantum sensing, and this refers to measuring some quantities with very high precision that has application both in fundamental science and also industry. There are many different companies which pursue developing quantum technology, and here you see a partial list of that, but there are more than 100 companies who works at it for different aspects to develop different aspects of quantum technologies, who work at for different aspects to develop different aspects of quantum technologies. This range for developing superconducting circuits, miniaturizing atomic system and nanofabrication, photonic A structure and also atomic structures, and different technologies uses various platforms and various materials to develop the technology. We will discuss these different materials and different and advantage of different materials. As an example of the goals of this course of this video is to introduce engineering challenges in various technologies. For example, to build a quantum computer, you need to build a processor that is compact, the possess very small amount of noise interface and can be able to be integrated with the algorithm layers such that we can have efficient connections and connectivity between various elements inside our computer. And also the low power consumption is another issue that we need to resolve. And overall there are various issues that we need to deal with various areas engineering challenges that is somewhat are different from what what we are used to in classical processors. We need to carefully engineer and design a system such that we can make enough numbers of quantum transistors to build a useful quantum computers. To understand the challenges involved in building a quantum computer, for example a quantum communication systems, first we need to understand what are the governing principles of such a processes. What we mean by decoherence, what do we mean by no noise, what do we mean by laws, and what do you mean by quantum algorithms. And by understanding this concept and also building mathematical ground, we can try to mathematically describe some of these phenomena, some of these challenges. And then after that we will talk about how someone can build such a processor as and what are the engineering challenges and how we can address those interesting challenges. The main sections, as I described earlier, in the first part we talk about fundamentals of quantum mechanics. So even if you do not have a solid background in quantum mechanics, in the first part of the course we try to provide that background and talk about how quantum mechanics got started, what are different important concepts that we will use to explain some of the quantum technologies. And this includes the wave particles duality, the light atom interactions, the Hamiltonian and the Heisenberg uncertainty principle, implement and noise, and so on and so forth. I supposed in the second part, as I mentioned, we talk about quantum resources of photons. So I hope you enjoyed in this video, and I have reached in the end of the video. And if you like this video, give it a thumbs up and